for this particular prompt, which is our last problem of this chapter anyway, I want you to go ahead and look at this graph right there. I have a graph for you. I want you to look at the graph carefully and tell me, state the vertex and state the roots. I have number 3 for you later on, but for now, just go ahead and take about 30 seconds or so to locate the vertex and the roots of this graph. Go ahead. Maybe I should zoom in a bit closer for you to see, but this is what the graph looks like. Of course, each increment is increment of 1, by the way. So, can you look at the graph and tell me? Of course, don't tell me yet. Just keep it in your mind for now, and I'll call on you. What is the vertex? Also state whether it's a maximum or a minimum vertex. And also, if you have 1 root, 2 roots, or 0. And if you have 1 root, of course, you state where that root is. And if you have 2, state them as well. Okay? About 20 more seconds. Look at them. So you have a good look at this graph, right? Okay, I'm going to zoom out right now. All right. Please raise your hand if you know where the vertex is. Santino, go ahead.
Those 2 right there.
Vertex. Vertex, right? Vertex.
Max.
Okay, can you tell me where that's located? What's the location of vertex?
0, 2.
Okay, there it is. 0, 2. Right there. 0, 2. And that is the vertex. All good. Okay, next one. Here's the next question. How many roots do we have, Alori? 2. 2 roots. We have 2 roots. Okay, good. Clearly because the graph is crossing over the x-axis how many times? 2. 2. Okay, twice. X intercept, roots, same kind of deal. All right. Name the first root for me, please. Where is it located? Go ahead, Ann. -1, 0. Okay. All right. It's right here. -1, 0. And, of course, the other roots, please. Go ahead, and Isaiah. 1, 0. Good. I'm glad that you're not mixed up with the 0, 1, 1, 0 kind of deal. Remember? X first before Y. So we got our 2 roots. We got our vertex. And so the third question is, if this is the information that we have here, oh, by the way, there's another thing, though. The graph is upside down, right? Yeah. Opening downwards. But yesterday, we did not, I don't know if I covered this with you yesterday, but there's a way for us to determine whether it's opening up downward or upward based on a certain value of the graph, of the function. Did I say that?
Yeah.
Okay, what is it that determines it? Well, yes. Which is, what letter is that? What coefficient?
1.
What determines it?
The negative or positive.
Okay, well, let's talk about that. But anyway, so we have this information. The graph is upside down. We have the vertex as 0, 2. We have the 2 roots as -1, 0, and 0, 1, 0. And so I'm asking which function matches up to this graph. So I have 4 functions right here. Okay? Any function up here, A, B, C, or D, could potentially be the function to the graph itself. Your job now is to determine, well, which one is the correct one for the graph?
C or D.
Okay? Okay, now you said C or D. Now, based on that, why did you eliminate A and B?
Because you said that if that thing goes down, it has to be a negative.
What has to be negative? The first number in front of what term?
X.
The x term?
No, the first term.
First term, which has what degree?
A.
Second degree. Square, right? And what is this coefficient again? What letter is that? A. So that's what we're saying. When A is, that's what you want to say. When A is positive, you know that the graph has to open upward, right? And when A is a negative value or less than 0, the graph will open downward. That's the reason why Santino said we can go ahead and eliminate A and B, because the first 2 coefficients right there are positive. Positive means I expect them to be opening upward, right? Of course, we're assuming everything's in order as well. Make sense? And another thing too is, if you notice that every single one has what term missing? The x term. The x term means what coefficient is missing? B. Okay. Remember our standard quadratic function looks like this: y equal to 8x squared plus bx plus c. This is the standard form of it. Everything has to be accounted for. If it's missing, that means that term will become a 0, right? This is called a quadratic function. Do you now know that when we replace that y with a 0, we are solving for the x-intercept? That's what we learned from way back, linear function. Remember, when we set x equals 0, we solve for y-intercept. When we set y equals 0, we solve for x-intercept. This is the reason why we're replacing the y with 0, because when we set it like that, we are solving for the x-intercept. And we also learned that the x-intercept is also known as roots. Okay? Okay, based on this right now, we have C or D left to determine. We have to figure out which one is which. Can you actually take one and solve for the vertex?
Yeah.
All right, let's say I'm going to pick C. I'm going to pick C right there, and I'm going to solve for the vertex. If I'm picking C, how do I solve for the vertex? What do I use? Very good. So for the vertex, I need 2 points. The order pairs, x and y. To solve for x, I'm going to use x equals to negative b over 2a. That's how I solve for the vertex. What is my b in this case?
-2.
No.
Oh,
-2.
0.
See? When it's complete, I need to have 3 terms, right?
Yeah.
Clearly, you see something's missing. What term is missing?
0.
The b term is missing. So b is 0. So I hope you also see a pattern here that when the b term is missing, the x part of your vertex will always be what? Because 0 divided by any value here down the bottom is going to become what? 0. So I don't have to plug in a to show you, unless, but at least x is 0. That's what you know. But if x is 0, how's that going to influence this? If x is 0, this whole thing will become 0, right? So 0 minus 2 is? -2. So that means my vertex is at 0, -2. So next time we see something like this, when the b term is missing, you don't really have to solve. You can just know that, oh yeah, since the b term is missing, x is going to be a 0. If x is 0, this x squared term will go away, and so y is just whatever it is. So it's 0, -2. But clearly, the vertex is at 0, 2. So which one is the one that has to match it up?
D.
D it is. So therefore, I can just clearly show you that D is the right answer. This is the kind of information you want to use from your graph to choose the right function. Does it make sense?
Yeah.
But now that you see it in this format, and you know when you solve for the vertex, it's always going to have a 0 for the x component, and the y component is always that last digit. Then it makes everything easy for you from now on if you were to graph it quickly. Okay? Any questions so far?
No.
All right. So now that we know that the graph actually contains a lot of information, guys, that you can actually extract from and be able to use that to form your function. So I just want to remind you again of the 2 variations of function that we have here. It's just like the quick summaries of everything that we've learned so far. Okay? First off, oh, look at that. Okay, whatever. First off, I have this. This is what we call a standard form, a quadratic standard form, right? Just like we have the linear standard form. This is called a standard form. Y equals ax squared plus bx plus c. When you set the y equal to 0, you are setting yourself up to solve for the roots, or the x-intercept. Is that true? And how many ways can you solve for the roots? 3 ways. First way, we can do the 0 product property, right? Factor, and z2p, 0 product property. Second way, we can do what? Or complete in a square.
Completing the square is easier.
Okay, if you like that, use it. Third way, Quadratic formula, which is the x equals negative b plus or minus b squared minus 4 times a times c, everything over 2 times a. That's the third way. This is what you can use to solve for the roots, based on the standard form that we have. And notice the standard form, yes?
Negative b what?
Plus minus.
Oh.
Notice that standard form has to have everything there accounted for and in order, right? From the highest degree to the lowest degree, all the way down to the constant. That's what they are. Questions? And I also taught you that by completing the square, you can also write it in this format. And this is what I want to show you. This format right here, that I just, remember it resembles us? This is called the vertex format. Vertex form. Because if I ever give you this kind of form, do we need to solve for the vertex? Have you seen that form yet?
No.
You have not? Did I show you yesterday that if you complete the square, you can actually write in that form?
Oh, yeah.
Yeah. If you write in that form, then you do not need to perform the x equals to negative e over 2a to solve the vertex. Instead, guess what the vertex is? It's right there. You just pull it out. It's the opposite of what the value inside of these parentheses is, and you just pull that in k. That now is your vertex. If it's written in that form.
Wait, what's the h?
It's any value. But that h makes up the x component of your vertex,
Okay.
and k will make up the y component of your vertex. Okay, so if it's written vertex form, you can actually extract the vertex that way without having to do this. What I'm saying is this: without having to do, if I give you the following, this is the standard form. Then if you were to find a vertex, you have to go through this to find the vertex. This is the x component. Remember that one?
Yeah.
So if it's written this form, then you have to go through this process. Or if you don't want to go through this process, you can complete the square to put that in a vertex form. Okay? So we're going to review that tomorrow too. So please come back with good questions so we can get this on. Okay? All right. So it's just a quick summary that we have here. Let's move on to our next example. Take a look at this graph. Very similar to the one we just did for the prompt, but this time there's a slight variation. Read carefully. Which equation best represents the parabola graph below if it is shifted 3 units to the right? So you take that whole graph and shift that graph 3 units to the right. If I shift 3 units to the right, go ahead and raise your hand if you have the answers. What is the new vertex going to be? Where's the location if you were to shift that whole graph 3 units to the right? Isaiah? Right there. Right there. No, I need an exact coordinate for that. Where is the new vertex going to be?
No.
Okay, wait. You say
3,
negative 1, negative 3 is right here.
3, negative 1.
3 units to the right. 3.
Negative 1.
Very good. You just take that point, shift it 3 to the right. Good. Next one. What else can I shift? Do you know your roots yet from the original graph?
Yeah.
Can you also shift them?
Yeah.
Good. So what is my new roots location going to be? Okay, what is it? 4, 0. Good. 1's right there,
And 2.
and 2, 0. So that means your new graph will look like this. Make sense? I just take that whole thing, shift it 3 units to the right. So here's the questions. Can you match it up to the right graph based on the information that you have? Now, I want you to see something. Have we seen something like this before, where the b is missing?
Yeah. No. We just did it right now.
Yeah, we just did it like last problem. If the b is missing,
The 0.
that means the vertex will always have a 0 in front, right? But look right here. There's a vertex have a 0 in front? No. So what can you conclude about f and g? Will this be part of my answer? No. So you got to be smart about this. You got to recognize, or if you don't remember any of it, you can still find a vertex for every single one. Is that true? That's an option. Or if you know the pattern, you can certainly say, well, this one for sure I know how the vertex is going to start with a 0. And the graph is just going to move up or down like that on the y-axis. Not going to go anywhere. But this is not our case. The graph is moving horizontally. Okay, now you just add down to this one right here.
Which is negative?
Which one would you like to test to see h? Okay, let's test h. If you're testing h, let's solve for the vertex, right? How do we solve for the vertex? How do we solve for the vertex? X equals 2, negative b over 2a. Vertex, right? Vertex is a point, so I need to start solving for x. So what is my b in this case?
6.
Which one are you doing? H or
Negative 6.
okay, negative 6, okay. And what is my a? 1. Solve for that. I have 6 over 2, which is 3. So that at least my points start. Oh, look, 3. So at least I have that. So if I take that 3 and plug it back where? Into x right here. This is what I'm testing, right? So if I plug it back in there, what do you think I'm going to have? What do you think I'm going to have if I plug it back in? What is it? Negative 1. Yes. 3, negative 1. And therefore, this matches up to the graph that I have. Or, do you also realize that you can actually find the roots by factoring? If you factor this one, I'm just going to prove it to you here. If you were to factor this x squared minus 6x plus 8 equals 0, you factor that, don't you have x, what? Minus 4, x minus 2? Because negative 4 times negative 2 is positive 8. Negative 4 plus negative 2, negative 6. Solve for that. Don't you have 4 and 2? And look at the roots. 2, 4. Match it up correctly as well. Mark.
Could you explain that negative 1?
Which one?
The negative 1.
This?
No.
There.
Oh, why? Oh, after you have this x, right? You were to plug it back into your function and solve for y. If you plug it in and solve, you get back negative 1. Okay, to complete the point, because that's what you're trying to solve for. What?
3 squared minus...
Look, 3 squared is 9. 9 minus 18, that's negative...
7, 8, 9.
Wait. 9 minus 18, that's negative 9, right? Negative 9 plus 8? Negative 1. Make sense? Okay. Check this out. I want you to go ahead and tell me. I don't know what you're going to try to do in this problem, but I just asked this. How many times does this graph intersect the x-axis? What would you do to determine? What would you do to determine the number of times this graph will intersect the x-axis? Any idea? Give me a strategy. Yes, Jennifer. What would you do? Oh my gosh. Yes, it is. Solve for the discriminant. Isn't the discriminant tells you how many solutions you're going to have? In a way, solution meaning how many times it will cross over the x-axis. Let's just say that you don't want to solve the discriminant. Is there another way to do it? You can actually graph it. You can actually graph it to see it for yourself, right? You can find a vertex.
So we're finding the roots?
If you want to. Yeah, in a sense. I'm asking how many times does the graph crosses over the x-axis? Crossing over means the intercepts, right?
Yeah.
So I'm asking how many roots will you have? Prove it to me. How many roots do you have? So one said, let's find a discriminant, which is from the quadratic formula. What's the other approach? You were to graph it, right? But to graph, you need to have at least the vertex first. Do you know how to find a vertex? I'm still pushing you. Do we know how to find a vertex? How do we find a vertex? What is it? X equals 2? Negative b over 2a. That's how we start, because a vertex is a point. So, what is our b here?
Yeah. Negative B.
B. What is
negative
it?
B.
Just negative 3. Not an x, right? The b is a coefficient in front of the x term. So it's a negative 3. Don't forget the negative over the outside of b. Over 2 times? 3. You end up with 3 over 6, which ends up being?
1/2.
1/2. So, you can write 0.5 if you want to, and you can plug it back in to solve for y. You can do that, right?
Yes.
But for those of you who use the other approach, the discriminant, what did you find out? Let's see. Remember, the discriminant is just the part inside of your root, right? So look, x equals to negative b plus or minus b squared minus 4 times a times c, everything over 2 times a. This is the discriminant part right there. If you want to plug in everything, fine. Let's plug it in anyway for practice. you end up with negative of a negative 3 plus or minus negative 3 squared minus 4 times a, which is 3, times c, which is 4. Try to write 4. Okay, over 2 times 3. Let's focus on that first. What is negative 3 squared?
9.
9. What is negative 4 times 3?
Negative 12.
What's negative 12 times 4?
48.
Negative 48. Whoops. 9 minus 48 is a negative value. And what did we know about having a negative value for a discriminant? 0. So that means this graph will not cross over the x-axis at all. And by the way, if it doesn't cross over the x-axis at all, and it's opening upward or downward? Think. Where are things going to open? Upward, right? It's opening upward and it doesn't cross over the x-axis at all, so where should I sketch this graph? On top. There it is. So somewhere like there. I'm just making a rough sketch, but at least you see what's happening. Because it's opening upward and does not cross over the x-axis, we have 0 roots, just like how we got the negative for the discriminant. And it has to make perfect sense. Everything has to tie into each other.
Why did we use the quadratic formula?
Oh, because notice that I'm trying to solve for the roots, right? But in the process of solving for the roots, notice that we have the discriminant in here. The discriminant is just like a warning sign that tells you if it's a negative, no roots will be found, so you can just stop. If it's a positive, you can just continue because you will have 2 solutions at the end. If it's a 0, you have only 1 solution.
Okay.
But in this case, because we got a negative, we stop. And we just say no roots, meaning the graph will never cross over the x-axis. If this had been a positive value, you would have a graph that it will cross over the x-axis. You see what I'm saying?
Yeah.
All right, that's it. And I think we're quite done. Here's your record of problems for tonight.
The same like yesterday.